So the previous video section went a full almost half hour. So this is part two of the recapping video. I'm going to go ahead and remove the caps that get replaced first. And I'm just going to yank them all in one pass, and then we'll come back and replace them. If you're more comfortable doing one at a time so you can match them up easier, that's certainly a good approach as well. They are, of course, labeled here pretty well on this. Again, if you look for Mac84 on YouTube, you'll find his video on recapping the 800. That's what I'm using as a reference for my recapping. If you find my video, look at his as well. But yeah, he's got this nice diagram. The red dots are where the positive of the capacitors go. The sizes, etc., are all on there. So that's a great little resource. And let's see about removing some capacitors. You don't have to use a desoldering tool to do this. You could heat and just pull the part out with the solder hot, and then maybe use some solder wick. It's really up to you. I'm going to say that didn't make a whole lot of sense there. And the plus looks to go right here. I prefer it when they just fall out like that. I've got one right here. Gain experience doing this kind of work, you get really used to looking at the front of the board and the back and going, okay, that's where connections are. I don't fight with it near as much as I did years ago when I first started doing this kind of work. You just kind of know. Any other electrolytics on here? There was the two there that were 10 microfarads. That must have been these little guys. Let me set that aside so I don't burn something with it. I should have these two 200 or 2200 microfarad. I should have the large. Oh, I see that I've missed one. There's a 470 here. I knew something didn't look right. And it is from here to here. We've got the two 470s and we've got the two 10s. And yep, those are 10s. Odds are these caps are just fine, but I'm going to go ahead and replace them since I purchased the replacements, and we'll just put them in a bag and keep them with the system. We've got two on this board to release. This guy here. Now there was a lot of copper pour there, and so it took a fair amount of heat to get that released, and it'll be the same way on this one. And I didn't get that one to release. I'm going to have to add some solder down there. Add some solder right there. Turn the pencil on. That's probably not the tip I want. That's a better tip. I see no signs of rework on the back of this board. It is really clean. Like I say, I believe this is, oh geez, fingers, all original. I really am this clumsy apparently. I want to just flow this, get a little more fresh solder on it. Like I said, it's taking a lot of heat. That's because of that very large copper pore. Okay, that dropped the capacitor out and cleared the hole. That's going to be another, I believe, 10 microfarad. And it is. It's identical to the other two 10s. And then we have a small electrolytic right there. I can see the plus on the board, which makes it easy to identify the positive lead. This is going to be the negative lead here. And it just fell out. So we've now got all the caps out. I'm happy with that. I'm going to capture them all inside of the... Well, we haven't got them all out. There's still 2 left to go. And that's the 2 big caps here. And the question becomes, is the tip I've got on here large enough to do the job? It does fit over the pin of the capacitor, so... This one released. Yeah, it did. Okay. We'll talk about these larger caps here in a minute. But I need to clear out some additional holes on the board here so the replacement capacitors will fit. We'll talk about that as well. I'm just going to add a little bit of fresh solder over where those holes are. As well as I'd like. That's better. That's better. Got some solder flakes here that I'm not happy about. Need to get in there and so, these larger capacitors have 3 pins. Well, that's kind of weird. With this pin, so this pin is labeled negative. This pin would be the positive. So this capacitor would have gone into these 3 holes here. And you can see that the 3 holes are not under my finger. The 3 holes there are all connected together. Let me kind of get this up, or maybe it'll be a little easier to see. The capacitor, I'll set it up here, has 3 pins. It come out of that hole, and that hole. But what you'll notice here is there's a copper pore between these. All 3 of these pins are ground, and these 2 are plus. And they do this so that they can use different size capacitors in there depending on what they can get. So as long as we get an equivalent capacitor really between these 2 points, we're good. We don't need to worry about this 3rd point. And if we rotate this cap this way, it would be the same thing here, where these 2 pins that in this case are positive. So again, as long as I get a good capacitor between the plus here and over here, we're golden. Since we're here playing with this, let's go ahead and take a look. I've got my little peak ESR meter here. It doesn't really care which way the leads go. So 0.04 ohms ESR and 6812 microfarad. It's just so large it's hard for it to measure, but if I go off to that third pin, it's open or low capacitance because that third pin doesn't actually attach anywhere. So yeah, this third pin is just floating there. It's just for physical support to help support the large weight of the capacitor. So I'm not convinced these two large capacitors are actually healthy. So let's pull out of the bag the two that are meant to replace them. And you're instantly going to notice here a huge difference in physical size, and we'll talk about that as well. So this is a 4700 microfarad 16 volt, and this is a 4700 microfarad 25 volt. And this is what's happened over 40 years of technology moving ahead. It used to take a cap this big to get 4700 microfarads of 16 volts, and now you can do the same thing here in this size with a higher voltage rating. And notice this is a Nichicon cap, so it's a high quality cap. And the other thing, you probably can't see it, it's a 105 degree C cap. Most caps by default are 85 degrees. So this is a quality capacitor here. I don't recognize the manufacturer of this one, TPO. This was an 85 degree C cap. So this Nichicon, it's smaller, but it's a high quality capacitor. So it'll make a really nice replacement. You can always replace capacitors with higher voltage. So that 16 volts is the working voltage. If you got above 16 volts on this capacitor for any period of time, the capacitor would fail. The dielectric material that holds the plates apart in the cap would fail. The capacitor would most likely short and potentially explode. This capacitor can work up to 25 volts, and it's just, again, better technology. So this is a tougher capacitor. It can also deal with higher voltage. In this case, that delta is not, it doesn't matter that the voltage is higher. The capacitance needs to match. The higher voltage is just no problem. You wouldn't want to go to a lower voltage in a replacement, because that would put the capacitor in a place where it could fail. So let's see what the peak says about this guy. Same ESR, and spot on 4700 microfarads. But the little peak meter here, I don't need to worry about polarity. It figures that out. With other capacitance in ESR meters, you do need to worry about the polarity of the clip leads. See, the peak just figures it out. These are both spot on capacitance-wise. These may very well be larger capacitance. There should be no charge there, and I think the peak actually discharges the cap as well before it attaches it to measurement. This is a really nice little tool. It's struggling now. There it goes. It just saw the cap as a dead short, which is interesting, which is bad. So let me make sure we actually get it discharged here. Put the leads back on the same way. So maybe these caps were starting to get flaky. I think these actually just are aged out caps. So we've talked about that higher voltage isn't a problem, rating on a cap. We've talked about the fact that that's a 105 degree C cap. That means that if you looked up the life expectancy of this capacitor, you would get that expectancy from it with a capacitor in a 105 degree C environment. The life expectancy of this capacitor is in an 85 degree C environment. So if it was 20 degrees hotter than the 85, this capacitor's life would be reduced, significantly. So this 105 degrees C is really desirable because they're near this heat sink here. So the large metal plate obviously is a heat sink. There's an LM340T-5. It's a 5-volt 3-pin regulator there. And there's a 78M12, I believe, there. That's a plus 12-volt regulator. This one's probably going to get fairly warm. I would suspect the design of the power supply is using this 33 ohm resistor here to drop some voltage, so it's not working as hard. But yeah, these caps, these are just a great replacement. So the plus is also in the PC board layout there. Another solder flake, it sure is. So it's interesting I have the plus there. Oh, it's way up here is the plus. So white stripe normally goes to the negative. You can see little negative symbols in it. And the short lead is normally negative, but look and make sure. So in this case, based on the width, this capacitor is going to have to go into those inner holes that weren't even used by the previous cap. And the same thing's going to be true of this guy. Short lead is negative. He's going to sit in here. So what we've done here is we have gone to a higher voltage set of caps. They're of course new. They're Nishikon, which are great capacitors. Great high quality capacitors. I'm bending all the... I'll just straighten that all up before I put it back together so I know it's straight. I'd say the assembly quality, what I'm seeing here is really excellent. They really put a lot of effort into this design. I'm going to flare these slightly. I'm going to verify them one more time are in the right orientation. Plus is there. Plus is there. They look correct. And we'll just go ahead and solder those up. These are some large copper pores. So a bit of patience, depending on the pencil you're using. It may take a little longer than it is for me to actually get it to flow. I'm not super happy with how that one looks. My JBC pencil here is a high thermal capacity pencil, and and it really deals with these large copper pores well. There are heat relief or tabs designed into this as well, in this really large pore, so that's good. So, but yeah, it handles these kind of large pores just super well. You look at the quality of those; they look fine to me. We'll trim the leads. I'm happy with that. I feel like that's a nice upgrade. That's a nice fresh capacitors. The next largest ones are going to be these ones here. These are 2200 microfarad 16 volt. What came out of the unit were these. So these are 2200 microfarad 16 volt. So again, that's just a difference in technology. They're both 16 volt caps, but they've been able to shrink the caps pretty significantly here with the same capacitance. This is a Nishikon. It's going to be an 85 degree C. I'm not surprised by that. It's far enough away from the heat sink here that it's not going to be picking up a lot of heat. C204 is a 2216. And there's one there and one there. So I'm going to do a little bit of playing here. I'm going to rebend these leads into the original width that they were, so I can use them as a guide. Let's see if the other one was bent to the same spacings, and it looks like it was. We're pretty close to it. So what I need to do with these is I want to bend the leads such that I get a nice clean installation. And I also want the markings to be up. So I'm going to bend this lead approximately there. I'm going to bend this lead approximately here. And that gets me very close to the same spacing. I've got negative back that way. This guy should drop in here just no problem. And it just drops right in. I like that, so the spacing is close enough that it just dropped in. I'm going to flare these out a bit to hold it in place. I've got positive to positive, negative to negative. I'm happy with that. Happy with that. It looks nice. And we're going to do the same thing here. I want to kind of have the markings up so that you can see them when it's installed from the top. I always recommend that. Check polarity one more time and it's good. Not a difficult job here, just slow and steady. Double check things. Okay, I see what that... There was an extra hole that didn't appear to have a lead in it, and it actually does exist on both sides of the board. There's a ferrite bead, it looks like, right here. There's simply a plate through to this trace that runs through here, if you can see it, and then the lead for the capacitor there. And I didn't see a lead in this spot right here, and I wondered why. That looks like a slightly bad solder joint. Oh, again, that's on the metal can there. It's not one I made. We've replaced those. We now have 470 and 470, which I believe is going to be this guy and this guy. Don't dump out of there. 470, 25 volt. 470, 25 volt. That is what these are. 470, 16 volt. So these are again an upgraded, it looks like, capacitor because they're rated 25 volts. They are 85 degrees C capacitors as well, which is fine. And that's the same exercise. I'm going to try to bend the lead. So physically these are about the same size, but these capacitors here are 9 volt higher rating, the newer ones. So that's fine. He's going to go right here, and hopefully I've bent that so it just drops in. And it did. Wow, I'm really pleased with the build quality of this 800. The soldering looks really good. I like the design. It's a very retro machine. I know that they way over engineered the RF shielding because at the time the FCC rules required it. And then after this design was complete and gone to market, the manufacturers petitioned the FCC and the rules were loosened up for basically RF interference that a computer could create. And that's when you got to this systems with the sheet metal, sheet metal, RF shield, that kind of stuff, versus this highly shielded machine. This uses the SIO bus Basically, because they couldn't bring a parallel bus or out of the system without generating so much RFI that it wouldn't get through the FCC testing. So my understanding is that's where the SIO bus concept came from. So it's engineered very well. I'm very happy to have it in my collection, and I'm really looking forward to playing with it. This is one of those where I really want to spend the time and learn to program on the thing, play with the basic language. I'm already kind of blown away at the things I'm able to do, just mucking around with basic on it. So positive, again towards the top. That one didn't drop in quite as cleanly, but it's okay. I'm going to go back and reflow that one, because after I pulled the soldering pencil away, the board moved and the capacitor wiggled, and the lead was wiggling while the solder was hardening up. And so I reflowed it just to make sure I got a good solder joint. So those are all in. We have C211 here and C210 that are both, I think these are 10 microfarad, yeah, 16 volt. That's 2 of the 3 of these. There's going to be 3 of those in here. We're going to pull 2 out because we're going to replace them. These are again TEPCO, whatever that brand was. These didn't look to be Nishikon. I don't know who the manufacturer is. Again, 85 degree. Oh no, they are Nishikon. I take that back. I see it now. And again, Nishikon caps. Very nice, high quality caps. I really like this as a refresh of the capacitors. Kudos go out to Console 5 for providing real nice high-end capacitors in this kit. I'm very happy with it. I'll go ahead and just pre-bend both of these because I can. Attention to detail, like getting the markings upright on the cap so that you can actually read them without having to remove the cap from the board. Those little kind of things to me make a huge amount of difference. This one it could have done a little bit better on, but it's still, you could read it from the top of the board. He's going to go in there, and those are a little bit tight, but it is what it is. And positive is the same orientation there. And that one drops in a little bit off as well. That's okay. Not the end of the world. Yeah, the build quality on my Atari ST didn't seem nearly as nice as this. Everything's socketed as well. It's just like, wow. What an incredible piece of engineering. Maybe as later generations happened, maybe they moved away from sockets, etc. But now we're going to do a visual inspection. So positive is there, negative's there. So positive is there, positive is there, positive is there. The negative, of course, pointing back that way. Positive is there, positive is there. Positive to positive, positive to positive. Happy with that. Very happy with that. Now we have 2 capacitors on this board. We've got this little electrolytic there. That is not that guy, it is the one in the bag here. There's 2 capacitors left. There's this little tiny guy here. He has 10 microfarad 50 volt. Oh, it's 105 degrees C cap again. Not that it's really important down here. It shouldn't be a hot working environment. And I think the one that came out was not 50 volt. It was 16 volt. So again, there's the difference in technology over 40 years. They're the same basically physical size. 16 volt on the old one, 50 volt on the new one. And 105 degrees C, so it's a really nice cap. So the board does have a plus symbol, so the capacitor does go in like so. Flare the leads just enough to hold it in place. And we will solder it. You probably saw it happen there. It rocked as that solder set. So I'm going to reflow it just a bit. That rocking, it's not up flush tight against the board. I'm not going to worry about getting it up flush tight against the board. It's insufficiently fine there. And we've got the spiking cap sitting where? Sitting over here, right there. The old one that came out is right here. Okay, this is why that spacing's okay. I was going to say this is why those other two didn't fit as well as I would have liked, but I know I dumped it out. There it is. Little comment here on why I clip these leads out and don't pull them out of the tape. If you pull them out of the tape, it tends to leave a little bit of glue residue on the lead, and when you poke the lead through the hole on the board, that glue residue can transfer into the plate through on the board, and then it makes the soldering messier and more prone to failure, in my opinion. So I always clip the lead so I don't have a chance of getting any of the glue that holds the paper in place on there. So again, Nishikon, we determined that before. It is 10 microfarad, 63 volt. Wow. What came out of there voltage-wise? Did we compare? 16 volt versus 63 volt. Holy moly. Again, same physical size, original rated to 16 volts. Modern rated to 63 volts? Yeah, it's not 6.3, it is 63 volts. Amazing. So, let's get the leads bent up here. With the markings up where they can be seen. Positive is marked on the board, both in the silkscreen and in the copper. You should go in there. I've got him in the right orientation. Got a large ground port here. There is thermal reliefs in that pad. It seemed to take solder just fine. But again, you're working around a large copper pour, so it requires more time to get things up to temp and to flow. Happy with that. These guys are going to need to be straightened out again so they're nice and pretty. Were you really in that crooked, or did I do that? I think there it is. Plus to plus. Plus to plus. I've double checked. Everybody's in the right orientation. I'm not going to remove any of the logic. I wonder what this is for. Oh, that's interesting. This has only got the right cartridge. It doesn't have a left cartridge edge connector. You can only put one cartridge in? That's rather interesting that it only can take one cartridge. Was there never a right cartridge? Huh. I'll have to research that. So at this point, it's just going to be the reverse to assemble it. So I am not going to record me assembling it unless something odd happens. I think we've talked about the caps. I'm happy with the replacements. Things have gone back together well. So I've got 3, 2, 1, 2, and 2. That's all the original caps back in. And I'm going to seal the bag up because I am going to keep these. Again, I'll finish up here with a quick shout out again to Console 5. Thank you for being there. This is not a paid sponsorship or anything like that. They don't even know I exist, except that they mailed me some stuff. But again, I was happy to find them. Like I said, they appear to be here in the US, which is really cool. I'll wrap this one up, and I'll see you probably on the keyboard swap out in the next video.